All right. Welcome back, ladies and gentlemen. I hope you had a wonderful spring break. I hope you enjoyed moving to different parts of your house, apartment, wherever you are, and enjoying just a new change of pace, new scenery. Okay, so we are coming back to start with our last two units. So we're almost there. Y'all doing great. We're almost done. Okay, so our next unit that we're going to talk about is we're going to focus a little bit on something that is a kind of different than anything else we've talked about so far. We're going to talk a little bit about the idea of electric forces and a little bit about the idea of electricity in circuits. Okay, so this first video is all about just getting started with the idea of electric forces. Okay, and we're just going to kind of walk through the notes. I'm going to talk you through it a little bit. It's only going to be the front side. The second side of these notes that will be posted on Canvas are going to be a different video because that's going to be a lab you're going to work through. Okay? So, the first thing that I would like you to do, okay, is we're talking about electricity, electric forces. You've probably heard or even dealt with this, especially in engineering classes, with various kind of electrical terms, things of that nature, especially in chemistry. I want you just to kind of brainstorm. Just type whatever you want for the next maybe 90 seconds. Just kind of brainstorm whatever you can think about electricity and literally just kind of dump everything you can think about on this document. Because we're going to kind of pick and choose and maybe come back and see how important some of that information is and how it relates back to what we're going to talk about. Okay, so take about, I said 90 seconds. You don't even need that. Take about 45 seconds. Okay, take about 15 more seconds. Start wrapping up. Last couple thoughts. Just kind of get a couple. You don't need to have a whole paragraph. Just a couple things on there. All right. So, of course, in class, this would be the point where I would have you share with your group members, talk amongst yourselves, see what you kind of had in common, what you had that was different. Of course, in here, we can't quite do that. So, honestly, I'm just going to kind of, off the top of my head, think about a couple things that might be relevant to electricity. It might be important. So, ideas about like circuits, thinking about maybe things that cause electricity. We could talk about batteries. Maybe the idea of the term voltage, some of you might have heard, or current. Okay, and even if you just heard of these things and you're not really sure what they are, we're going to talk about these things by the end of this unit, I promise. Okay, maybe the idea of, I don't know, electrons. Someone might think that's important. Conductors, insulators. Okay, and it's kind of cheating because I know all the answers, so I'm coming up with some things that seem kind of like, wow, that's amazing. I trust whatever you came up with. Maybe static electricity. As you can clearly see, my spelling skills are really top notch right now. Okay, now with all these cases, and I'm just going to highlight this in blue so that we know these are kind of the notes. In all these cases, we're going to come back to the idea that everything that we just kind of brought up are going to deal with basically the idea that there's a new type of force in town. Okay, and it acts a little bit differently than the forces we've talked about. It relates very similar to one specific type of force, and it doesn't really relate to the other ones. Okay, but to talk about that, we have to kind of refer back to the three electric amigos. All right, and of course, if you've gone through chemistry, if you've talked about the atom at all, you hopefully have it kind of in your mind what the three electric amigos are. And in our case, they are going to be three very important atomic particles. They're going to be the electron, the proton, and the neutron. Okay. Now, the reason that these matter is that these three particles kind of comprise all atomic structures in different orders. And then, I don't want to go too much detail because that's really more of a chemistry question that's not really important to us. But what is important is the idea of charge. And what I mean by that is that you'll notice, looking at this diagram, that there are three different particles, and yet there only seems to be two charges. Okay, now, charge is something that you've probably talked about plenty of times before, and even if you haven't talked about it in terms of electricity, you've probably heard the idea opposites attract. and similar things repel, this is where this comes from. Okay? And for us, what we find is that in all the charges that we talk about electricity, electrons generally have negative charge, protons have positive charge, and neutrons don't have any charge at all. Okay? Now, what that looks like, as we're going to show in a sec, is that works its way back to physics with the fact that different things attract or repel each other depending on what's going on. So the electron, the proton, the neutron. Okay? And then feel free to fill in what their charges are, negative, positive, no charge at all. Now, what we find with all these little guys is that they cause an effect on each other. Okay? And of course, we kind of just brought it up, but basically like charges, when we're talking about that, like charges are going to repel each other. Okay? And we can actually see that in a little demonstration that I have right here. So, this is called electric field hockey. Basically, this hockey puck right here is a proton, or it's positively charged. And what I'm going to do is I'm going to put another positively charged particle right here. Now you can already see as I start to bring it on here, this little arrow starts to pop up. Okay? Because what's happening is these two things hate each other. They don't want to be anywhere near each other. They want to get the heck out of here. Now this little guy can't move, just the way that this thing's set up, but this puck definitely can. So when I hit start, that puck gets the heck out of Dodge. Okay? And it's because, as we just talked about, similar things, similar like charges, repel each other. They don't want to be anywhere near each other. Okay? Now, if I flip this out, and instead of having a positive little particle, I put a negative one here, you'll notice that once again, an arrow starts to pop up. But this time, the arrow doesn't point away. It seems to point towards the negative. Okay? And this comes to the idea that opposites attract. Because if I hit start, all right, this thing starts moving, and it's attracted to that negative particle. Okay? Now, when you do your lab, which hopefully you'll do after you finish this video, and I post the lab section, you'll kind of see that maybe where I put this negative particle, or how many negative particles I put on there, affect it. But just kind of give you an idea, we'll just kind of observe it. I'm not going to say anything because I don't want to ruin too much of the surprise, but if I move this closer, the arrow seems to kind of go a little bit crazier. And then, of course, let's say I move it way far away here. All right. Well, and your whole point is supposed to score, so congratulations. I did score. Really, difficult challenge. All right. But the reason that I bring this up is just to show the idea that how these charges can kind of affect each other. All right. And in a little bit, we'll come back to this and show what happens when it's a bit more complicated. Okay. But that lets us fill in kind of these first things. So we can say like charges are going to repel each other. Another way of saying that is they push each other away. And opposing charges attract or they pull each other together. And you should already right away, you're hearing the words push and pull. That should tell you right away that they must be exerting something on each other. And going back to our fundamental kind of definitions of physics, this means they've got to be exerting a force on each other. Okay? And this is where the idea of an electric force comes into play. So once again, I'm just going to try to make these blue so that we know that this is kind of stuff that we wrote down. Okay? Now, going back to our electric hockey, this can get much more complicated. Just like any force question get more complicated. And don't let the fact that it's positive, negatives, all these weird things, electrons, neutrons, protons, all these new words, don't let it distract from the fact that it literally is the exact same thing we've been talking about the whole year. The idea that if there are forces and they push and pull, they're going to cause something to start moving or stop moving. Okay? And in this case, if I just have this one electron right here and this proton, they're attracted to each other, which means that they're going to pull on each other. And in this case, this electron is going to pull this proton towards it. And that's, of course, what happens to get it to start to score. All right? Now, there might be an interesting thing about what happens to the force as it kind of arranges the position. You might find out when you do your lab in a little bit. Okay? Now, I can also make this a bit more complicated. Okay, and actually, in order to do that, let's ramp up the difficulty a little bit. So, in this game, you can actually put walls in your way, kind of make it a problem. So, remember the last time when we did the easiest one, I put this here, and it just kind of won. This time, however, that's not going to work because it runs straight in there. Okay, and what happens is basically with electric forces, depending on where different charges are placed, you can cause some kind of weird things to start happening. And what I mean by that is, let's say I have this charge, and what I'm trying to do is I want to get this thing to start moving forward. So maybe I put a couple charges right here to attract it. But basically we're going to start seeing that this thing's kind of got weird arrows. Weird stuff starts to happen. So let's see. I'm just going to start. Ooh, didn't work the way I expected it. All right. And let's see. Let's take these little guys off. We'll take these away too. Maybe that's going to cause an issue. All right. And unfortunately, basically, if you want to run this, you're welcome to. You need to go to FET and pick electric field hockey. You have to use Java. So if you're running Windows 10, this is a kind of a aside, you need to actually run Internet Explorer, really go back in time and try and run Java so that you can play around with this. But basically, just kind of playing around with this and looking at it, what I want to show is the idea that I can cause kind of these weird forces to occur depending on where I put the charges. All right, and the same thing is true if I put a bunch of charges over here and I put a bunch of charges behind the goal. You're going to basically, if I drew an FBD, you're going to have kind of a force going this way and a force going this way, which means the net force is going to cause it to kind of go this way. All right, you can see all those little arrows that's representing all the different forces acting on it. All right, now, just to kind of talk about a little bit about the idea of charge before we do some practice. Okay, the unit of charge is a Coulomb. All right, now whenever we're talking about charge, we're basically measuring the amount of extra electrons or the lack of extra electrons an object has. And what that means is that an electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. It's really tiny. Okay. And there's actually a reason why the Coulomb is such a big number. We can talk about that when we start to get towards circuits. We'll discuss that. But what it means is that anything that's positively charged is missing electrons. Okay, it's got more protons than electrons. Okay, and then if something is negatively charged, it means it has more electrons than protons. Okay. Now, just to kind of reiterate, charge is measured by a Coulomb. That's just measuring basically the number of electrons something has, or the lack of electrons it has. We will practice this more, I promise. So, let's say I start, and we just have a couple just demonstrations. Okay, let's just imagine I put two negative charges next to each other as shown below. I want you to draw which way the charges will move. So just take a sec. This is an image, so you're welcome to actually, you can just click and edit the image. Okay, so take about 40, you don't need that, take about 15 seconds, if you could please, and just kind of sketch which way you think these things are going to move.